Okay, I'm going to go over problem number 3 from the back of your review. It says Misha walks 20 yards, so I can pick my direction because it doesn't say. So let's say she's going this way. She walks 20 yards. Then she turns 125 degrees from her original path. And that's kind of important because that means if she's facing this way, when she turns, she has to start facing this way and then rotate around 125 degrees. So the 125 degrees would be over here, which is more than a quarter circle. And after she turns 125 degrees, she then walks 24 yards. So it's a little bit longer, so that's 24 yards. And then asks, where does she end up with respect to her original path and location? Meaning the original location was here. So how do you get from there to the final destination? So notice that because I had two vectors lined up head to tail, and then I start at the beginning of the first to the end of the second, this is basically my resultant vector, the sum of these two. So I'm just going to call that R, vector R. And now I need to find the magnitude and the direction. In other words, if I need to say where she was, I need to say how far she had to go and at what angle. So first things first, let's find the distance. Notice we have a triangle here formed by R as usual. The 125 was outside the triangle, but because that's a straight line, I can say 180 minus 125 would give me this angle, so that's 55 degrees. And so since I have side angle side, I can now use law of cosines to find the length of R. So it's c squared equals a squared plus b squared minus 2ab cosine c. And then since I only have one angle to 55, that'll be my big C, which means across from it, R would be little c. So let's say R squared equals, and then a and b would be the 20 and 24, 20 squared plus 24 squared minus 2 times 20 times 24 cosine, and then the angle was 55. So since there's no variables in there, I can just go ahead and type the whole thing in my calculator. I make sure I'm in degree mode, which I am, and so then I say 20 squared plus 24 squared minus 2 times 20 times 24 cosine 55. I get 425 or so, but then that's R squared, so I take the square root of my answer, and I get 20.624. And that would be the distance that she has to travel, so I'm going to call that the magnitude of R. So I use the little absolute value signs to say the magnitude of R is 20.624, and that would be yards. So I've got how far she has to walk, but I also need to know which direction she had to go that distance in. So now this is where I have to go back and look at the question. Notice that when it says where does she end up, it says with respect to her original path, which means the angle I need to find is the angle from her original path. So since the 20 was the original path, I have to find the angle from the 20 to my R. So this is going to be my theta. And if I use law of sines, remember to solve for an angle, I have the case 1, case 2. So since I don't want to do that, I go back to law of cosines. And now since this is going to be my angle C, then the side over here has to be across from it. So across from theta here is that 24. So I'm going to start with 24 squared. So 24 squared equals, and then the other two sides are 20, and remember this side was 20.624. So 20 squared plus 20.624 squared minus 2 times 20 times 20.624 cosine, and I don't know my angle, so I'm going to put cosine theta. All right, so to solve, let's do our simplifying first. So I've got 24 squared is 576. Then I do 20 squared plus 20.624 squared. That gave me 825.349 minus, and then 2 times 20 times 20.624 is 824.96 cosine theta. So to solve for theta, I'm going to have to cancel out cosine, the 824, and the 825. Let's start over here. I'll subtract the 825 from both sides. So that was, here, 349. Subtract it over here. And so then I have 576 minus 825.349. It's negative 249.349 equals, and then that cancels, so negative, don't forget your negative, 824.96 cosine theta is what's left, which means I need to divide by the 824 to cancel that out. So I divide on the other side. So I've already got that answer in there, so just dividing by negative 824.96. And that will give me cosine theta is approximately 0.302 and so on. And so then to find theta, I have to cancel out cosine, so I do inverse cosine and then inverse cosine over here. So I'll do inverse cosine, and just so our answer's not too off, let's do second answer, and I get 72.407 degrees equals theta. So she needs to walk 20.624 yards, 72.4 degrees from her original path. And now I've got the final location.